Welcome to another exciting episode of Doug's Electronic Repair Bench.
Hi, evening YouTube. Here today with you to take a look at this IM-13 once more. What I'm doing is checking the linearity, whatever you want to call it, for the control for the ohms adjust pot that I cleaned. As you can tell, or you should be able to tell by the meter reading. Hope everybody can see that. It's on a 20K scale. The pot itself is a 10K pot, so that's the best we can do on that. I'm trying to see what we're up against here. Anyway, that's set down all the way. In other words, it's almost zero resistance right now. And I'm going to take and see if I can do this without getting in the way too much of the meter. As you can see, the resistance will increase as I start to turn this control. Now this is a gear reduction type control, so it goes up pretty slow. But you can just see as I keep turning, it goes up a little higher, and it seems to be pretty smooth. It's up to 3.5K, 3.6, 7, 8, 9, 4K. So it just keeps going up. So basically 5K would be the middle point. Right there would be right the middle point of that control. It's halfway between on and off, if you will. But so we're going up from there, and it just continues to go up just like it should. And I think this gets up all the way to, I believe 9, maybe 10 something. So that shows it's working over the full range. There you go, that's it right there. So that's pretty darn accurate. 10K. So that's the way I wanted to check that one. I just wanted to make sure it was right. I was going to use an analog meter for this, but I don't have one hand except for the other VTVM, which is why I'm working on this, to have an analog meter. So basically how you hook these up is you can go between the middle one on a potentiometer and either one of the outside lugs. It doesn't matter which one you use. You'll get the same type of reading, only one will go up where the other one goes down. So I'm going to try this again on the ohms adjust, or I'm sorry, the zero adjust pot. See what kind of reading we get here. Now this is in the circuit, so it may measure a little differently than the other one did. Let's see, we'll go all the way down here, and we're there. So you can see that's okay. That's all right. That's all the way down. Now, if you go up, you should see the same basic thing you've seen the last time. Might be going up a little slower. Now, what you don't want to see is, say it's on 0.88, and then the next time you turn it, it goes all the way up to 2 point something. I mean, you don't. That's a sign of a cracked not insulator, but resistance carbon ring. And I haven't seen that in this one. This one I did clean last night with a spray cleaner, the deoxit. That seems to be, it's pretty smooth. Seeing a lot of problem with it. Like I say, I hope everybody gets to see this. If not, I'll have to do it again. Like I said, it's not a big deal, but like I started to say, with the analog meter, you can see the needle move. It's a little bit easier to read than watching the numbers go up. I mean, the numbers are pretty consistently go up, and it's pretty easy to tell. Alright, there were, let's see, where was 5? Basically 5. Right there is the halfway point. So we can see it goes there. Alright. Now I'm going to turn this real fast and show you what I'm talking about. So you know that went up quite a bit. Now I'm up all the way. Now you're saying, well, why is it not 10? Like I said, there is resistors going to this this potentiometer, and where there wasn't any on the other one. Now if I go and move this lead over here to the other end, it should measure 10K. Oops, and maybe not. Now there must be something across it bringing the resistance down. That's normal. If I remove the wires, the resistors and everything from that, it should measure 10K. So anyway, that's good enough. That should give me the full range that I wanted. So that was one of the things I wanted to do, was test that. And now that I've done that, push this aside a little bit. This cord is always in my way. No matter which way that thing is pointing, it's in my way. This is what I was talking about getting in the mail today. I bought this for my Heathkit frequency counter. I thought it might come in handy to measure oscillators or something like that inside the radio, whereas I don't have a real probe for it at all. This is a oscilloscope probe. It doesn't much matter if you're measuring what are you using it for. It's got the BNC connector, and it's got the ground connector, and each little pops out, click on something. But you can use that to check your oscillator frequency. You know, a lot of people say you have to have a scope for stuff like that. Well, you can use a frequency counter for that too. Should be able to produce a signal on that frequency counter to see what the oscillator is running at. Like I said, there's more than one way to skin a cat here in the electronics world. Scope is a useful piece of equipment, don't get me wrong, but you don't have to have one to service equipment. You don't really need that much. There are certain things that scope is almost imperative to have for, but stuff like that is not one of them. And then, like I said, this will come in handy to measure frequencies of stuff that I have on the bench that I want to measure frequencies of. And it was very cheap. I don't know how much it was, but it's cheap. It's capacitance, has a capacitor in line with it, and it's got a times 10 setting on it. It's like there. That's times 1. That's times 10. So it's a nice little probe. That'll work real good for that. So that's really all I have this time. Still haven't figured out anything else on the meter itself. Like I said, if I set it up here into the 150 or higher range, I can zero the meter. And like I said, it's not perfect, obviously, but if I set it down to 50 volts or lower, then I get that erratic behavior. So I think the next thing I'll be looking at is probably this range switch, because obviously there's something causing that. Just not sure what. There's a lot of precision resistors on that switch. So, you know, one of them could be way off, I guess. It would have to be one of them that's common to all the ranges below 150 volts. So that's what I'll be looking for, is stuff like that. One of the guys on the antique forum, radio forum, said that check grounds on these. Ground connections get bad on them, especially from corrosion and things, and this one's definitely had some corrosion. So, like I said, we'll have to look at that. And anyway, just a quick little update on this, so thanks for watching.